This is the fast-paced solution of linking writing process to writing quality. So the agenda of this presentation, I followed the official template in this presentation, so I explained first background and summary and so on. So let's start with background. I am Tomoo Inubushi. I got PhD in cognitive neuroscience, but it's not related to deep learning or AI. And I am currently working at Japanese optical sensor manufacturer. I am using my data science and machine learning skills for medical data analysis for my job. In this competition, data science, machine learning, and programming, and data analysis skills for my job might help. But actually, 4 years of struggling in Kaggle competition was much more important, and this is my first gold medal. So let's start with the summary of my solution. This is a schema of my solution. But first, I cleaned the data and extracted keyboard activities, for example, mean, minimum, and max of interkey intervals. Next, I reconstructed essays from keyboard activities and extracted TF-IDF features. Third, I also used external data, and I anonymized essays of external data and extracted TF-IDF features. And next, I trained large GBM models to predict external scores from anonymized essays. Then, I used these large GBM models to predict external scores, and these scores are used as features. So then, I trained the model with features from step 1 to 3, and then assembled the predictions. And finally, predictions were clipped from 0.5 to 6.0 with post-processing. So I use various models, including LightGBM, XGBoost, etc. And from them, LightGBM was the most important and powerful models. And the most important features are TF-IDF features of reconstructed essays and predictions based on external data. I'll explain it later. And two I used was Python, Pandas, sklearn, etc. It takes 4 hours in Kaggle GPU environment for all steps of preprocessing, training, and inference. Now then, I explain feature selection and engineering. I use 378 features in total. They are stats of interkey latency, burst latency, and release latency. Total counts of each activity and event. Time to first reach 200, 300, 400, and 500 was. And pause-related features for time ratio, stats of reconstructed text, total counts of punctuation errors, pause and revision burst-related features, and TF-IDF features of activities, events, and interkey latency. The last two features are most important. Word level and character level TF-IDF features and predictions of external essay scores. Some of the features were from public notebooks by Hensen and public notebook by Katak. So most important features are, as I said, TF-IDF features. I'll show you variable important spot in next slide. And word level and character level TF-IDF features are concatenated and processed with truncated SPD to reduce dimensions to 64. And some float features are transformed to uniform distributions, and some integer features were robust scaled and clipped to from -5.5 to 5.5. This is a variable importance plot of light GBM. The top 5 most important features are TF-IDF158 and square GB 21, word length 9 count, and word length STD. I'll show you this relationship between these features and the target variables. This is a slide of a scatter plot from TF-IDF1 and scores. TF-IDF1 and TF-IDF58 were the first and second most important feature variables. They are nth components of TF-IDF features of reconstructed essays. As you can see in left scatter plot, TF-IDF1 and the score of this competition has a strong negative relationship. And the third most important feature variables are score LGB 21. And this is the prediction of the large GBM model trained on external data. 21 means feedback price. As you can see, they have a strong positive correlation between score LGB external 21 and the score of this competition. I think there must be some universal characteristics in essay evaluations, which are not removed by anonymization. The fourth and fifth important features are word length 9 counts and word length STD. They are a number of words with 9 characters and standard deviation of word length in essays. As you can see in left plot, they have positive strong relations between word length 9 count and scores. I think this is because the skillful student may use long words. So next are the training models. I use various models including light GBM requesters, classifiers, XCB requesters, etc. And I assembled them with linear regressors and logistic classifiers and took mean for final ensembles. But actually, after the competition, I noticed that single light GBM model has the best LB readable scores, actually. Important and interesting findings. I believe that the idea to use external data must be the key for this competition because only the first and third teams did so as far as I saw. I expected that it would add generalizability to my model. I also found an interesting relationship in the data. This is a histogram of action time, downtime minus uptime, for each activity types. I noticed that I found that action time varies depending on activity types. And when extracting keyboard activity data, for example, action time, interkey intervals, parse features, only using those with input features, as shown in orange in this histogram, improve the score. I think this is the secret in public notebook, Silverlight notebook by Alcatag's notebooks. I also found that storage peak in around 500 milliseconds. I'm not sure why, so I'm very happy if the host knows the reason. The simple model. I used 378 features, but from them, only TF-ID features and external data features, 88 features in total can achieve CV in 0.6.612. Also, for final ensemble, a single GBM can achieve 0.5784. So actually, single GBM model was better than my final ensembles. So that's all. Thank you.